Hi students, now let us see how can we solve nodal problem by using matrix formation method. So in the class we already seen how we can solve nodal problem by using conventional approach, that means by applying the Kirchhoff current law at the nodes. So now we'll see how can we solve the nodal by using matrix formation, right? So for that I have taken the same problem which we already solved in the class by using the conventional approach. Now let's try to understand how we can apply the matrix formation method for the same problem. Okay, right. So I'll start with first Ohm's law to form the matrix for the nodal. So you all know that Ohm's law, we can write it as V equal to I into R. Then I am going to rearrange this expression uh, because see in the nodal analysis voltage is unknown. So what I'm going to do, I'm going to keep the unknown parameter on one side and the remaining parameter on other side, and you know that I can write a current I as V by R now, right? So I just remodify the equation. So what I can do, I can make the first one as 1 by R, then I'll write voltage, then I'll write current. Okay, this is actually a Ohm's law, right? So now you see here I have made all our matrix. So do remember the size of the first matrix, that is 1 by R matrix, actually n cross n, where n is the number of unknown nodes. That means the nodes where we need to find out the voltage. V is the column matrix, the size is n cross 1. Current is again column matrix, size is n cross 1. Okay, so where n is the number of unknown nodes. Right, and here the 1 by R matrix we used to call conductance matrix. Why? Because 1 by R is nothing but conductance. So we used to call this first matrix as a conductance matrix, and generally the conductance is represented by the a unit called Siemens. We simply write that as S, or also we can represent conductance with the symbol called inverse of O. Okay, like this, right? So do remember the first matrix is conductance matrix, and second one is unknown voltage matrix, and third one current matrix. Okay, now let's try to form this matrix for this particular given problem. And we already seen in the class this particular problem having two unknown nodes, namely node 1 and node 2. So we have taken that node 1 voltage as V1 and node 2 voltage as V2. So now we'll keeping that, we'll try to make this matrix. So let us first form the conductance matrix. So here the size is 2, right? The n is 2. So we will generally have a 2 cross 2 matrix for a conductance. So let us form first 2 cross 2 matrix. So I'll take row 1 2 and column 1 2. Now here the element is 1 by R11, because see the general format is 1 by R now, right? So the first element is 1 by R11, the second element 1 by R12, then 1 by R21, then 1 by R22. Okay, then this next voltage matrix, so V1, V2, then current matrix I1, I2. So this is the general format for nodal problem having two nodes. If it is a three nodes, we can also expand this, right, by keeping the conductance matrix as 3 cross 3 and voltage matrix as 3 cross 1, current matrix as 3 cross 1, right? So if it is a three node problem, we need to write as 1 by R11, 1 by R12, 1 by R13. And one another important thing here, you know already, we always take the off diagonal element as a negative. Okay, the same we did in mesh analysis also. So here if you look at this conductance matrix here, R12, 1 by R12 as well as 1 by R1 both are off diagonal. So for that I need to put a negative. Okay, minus 1 by R12, minus 1 by R2. Okay, this is what the general matrix for nodal problem having two nodes. Right now we try to understand the individual elements here. See, the first R11 is nothing but the sum of resistors which are connected to the particular node number 1. And R12 is nothing but the common resistor which is connected between node 1, node 2. R21 again same, the resistor which is connected between node 1, node 2. And R22 is nothing but the sum of resistors which are connected to the node number 2. Okay, this is what the elements, each elements in the conductance matrix, right? And V1, V2 obviously unknown voltage that we are going to find. And I1, I2 is actually current correspond to the node. That means I1 is actually current correspond to the node number 1 and I2 is current correspond to the node number 2. So here in the sum of the problem, instead of current they may give a voltage source, right? In the class I already explained the conversion of voltage source to current source. You just adapt that method and try to get the current if they given the voltage source in the problem. If they given directly current source, you can straight away take the current value, and maybe some nodes may have an incoming as well as outgoing current. So based on that you decide, right? For example, if the node having only incoming current, then you need to sum up the all the incoming currents. If the node may having incoming as well as outgoing current, then you need to sum up incoming current and then you subtract outgoing current from that, right? So based on that you decide, right? So I repeat again, for getting this current matrix, you just look at the node. If you're having a voltage source on that particular node, you try to convert that into a current source and find current. If the problem directly given the current source, you take as it is, right? Now this is the general one. So let us make this matrix for this particular given problem, right? We'll try to find out all the elements here. So I'll start with first the R11, 1 by R11 value. Okay, see, I already told that 1 by R11 is nothing but the sum of resistors which are connected to the node number 1. So if you look at this node number 1, there are three elements are connected together, no, right? 5 ohm, 1 ohm, 0.5 ohm. So I'll keep all are now 1 by and I'm adding it. Okay, so that means 1 by 5 plus 1 by 1 plus 1 by 0.5. Okay, this is actually R11, 1 by R11. Then we need to know what is 1 by R12. I told already R12 is nothing but the resistor which is connected between node 1 node 2. You just look at here, node 1 node 2 in between we have a 0.5 ohm. So that is actually R12, right? And again it is off diagonal, so I have to keep minus 1 by 0.5, right? Then that is same for R21 also, same minus 1 by 0.5. Then next time we need to get 1 by R22. I told already R22 is nothing but the resistor which are connected to the node number 2. See, node number 2 having again 3 resistors, 2 3 ohm resistor and 1.5 ohm resistor, right? So we'll try to get now 1 by R22. So 1 by R22 means 1 by 0.5 and plus 1 by 3 plus 1 by 3. Okay, so now this is actually a conductance matrix. That's it. This is actually a conductance matrix, right? The next unknown voltage matrix, which is V1, V2, that we need to find out. Then current matrix. So this is a very important thing. Here you just listen carefully. So I told already for a particular problem having a voltage source, we have to convert that into a current source first. If the current source is directly given, you can take as it is. Okay. So now let's try to get first I1. See, I1 is current corresponding node number 1. Okay, you just look at node number 1. So this is node number 1, right? So in this node, there is a 25 volt battery is connected through the resistor of 5 ohm, right? So 25 volt, 5 ohm resistor in series. So this we used to call practical voltage source. So as per discussion we did in class, we can convert this voltage source into a current source, right? So if you take this 25 volt as a voltage and 5 as a resistance, 5 ohm as a resistance, we can get current simply by V by R. So 25 by 5 will give the current, right? So the I1 current is 25. Then now the next question, whether I have to take the 25 by 5 as a positive or negative, that we usually get by based on the polarity. You see the polarity is upwards, right? Plus is upwards actually. That means the current is upwards. So current upward means it is towards the node, right? It is towards the node. So for that case, I have to take 25 by 5, right? I have to take 25 by 5. Okay, right? So that is what I want, right? Because node 1 having only 25 volt battery. Now let us take node 2. So in node 2, there are two batteries, 30 volt battery and 3 volt battery. So see the 30 volt connected in series with 3 ohm and 3 volt is connected in series with 3 ohm, right? So now let's try to convert this two voltage source into current source. See, if I want to convert this 30 volt 3 ohm into current, I can divide, right? 30 by 3, I'll get current as 10 ampere. And you see the arrow mark is upwards because we have a positive polarity upwards, right? So current is towards, so I have to take plus 10. But if you take this 3 volt, you see here the positive polarity is down, so that means the current is down, right? When we convert this voltage source to current source, the current obviously down because plus polarity is down, right? So now if you see that way of current flow, it is like the current is away from the node, right? This current is away from the node. So for that I have to take minus 3 by 3. So that is going to be 1 ampere, right? So I can write here. First one 30 by 3. Okay, 30 by 3. Then second one minus 3 by 3. So why I'm putting minus here? Why? Because current is down, right? Current is down. While we convert 3 volt 3 ohm into a current source, obviously the current direction is down. That is like the current is coming away. Okay, that is going away from the node number 2. That means we have to take minus 3 by 3. Right now we will simplify this matrix. So first one, if you simplify, you'll get 3.2. Second one, if you simplify, you'll get minus 2. Here also minus 2, and this one I think yeah, you'll get 2.66. Then v2 v1 v2 is unknown. Then if I simplify 25 by 5, it is 5, and 10 30 by 3 10 minus 3 by 3 1 will get 9. Okay, so this is what the final matrix for this given problem. Now I can write equation by simply making the matrix multiplication. So it is going to be 3.2 v1 minus 2 v2, which is equal to 5. Then next minus 2 v1, that is minus 2 v1, 2.6 v2, right? That is plus 2.66 v2, which is equal to 9. Right now we can solve these two equations by using grammar rule, which I already explained in the class. So if you solve by using grammar rule, you will get the final answer as v1 6.83 volt and v2 as 8.3 volt. Okay, so this is the answer you'll get. I hope you understand the method. So for solving the nodal problem, either use this matrix formation method or the conventional method which we already discussed in the class. Thank you.